Okay, in this first video on velocity, we just want to look at the concept of velocity and understand the differences between average velocity and instantaneous velocity and the concept of vectors and scalars. In the next video, we'll look at example problems of how we solve displacement and velocity problems. Two terms that you need to know in this course are the difference between scalars and vectors. You need to know what the difference is between a scalar quantity and a vector quantity and the examples of the two and why that is important. A scalar quantity is any quantity that only contains magnitude. Now, magnitude is a large word that generally in our case is going to talk about value. So when you say something goes 10 meters, that's a magnitude. When you say something's going at 40 meters per second, that's a magnitude. Quantity that only has that magnitude value would be known as a scalar. So time is a scalar, 35 seconds, 25 hours. Mass is a scalar, it's 30 kilograms. Distance, 10 meters. Speed, 40 miles an hour, or 30 meters per second. Those are all scalar quantities. They only include a magnitude. A vector quantity is different in that it includes both a magnitude and a direction. So now you're adding in a direction to those magnitude quantities. And many vector quantities have a pair that is a scalar quantity. So there's a scalar version of many vector quantities. For example, distance is the scalar version of displacement. Displacement is the difference in position from where you started to where you finished. It's a distance and direction. Velocity is a speed and direction. Position tells you the placement and direction of an object from the origin. Acceleration would tell us a change in velocity and a direction. So anything that has a vector quantity will include a direction, whereas a scalar quantity will only have that magnitude value. In this case, we're looking at velocity, but speed would work just as well. The difference with speed is that we wouldn't include a direction since it's a scalar quantity. So you can solve for speed the same way you solve for velocity, you just wouldn't take into account direction. Velocity is a vector quantity that includes both speed and direction. So speed is the scalar quantity. When you add direction to it, you get the vector quantity, velocity. It's basically a measure of how fast something is going and in what direction it is traveling. The units for velocity will always be meters per second for this course, even though you may be more familiar with the units of miles per hour because of driving your cars. Now, when we talk about velocity, we are generally talking about average velocity. Average velocity is found by doing the displacement divided by the elapsed time. So we get the equation average velocity, v with a line over it, equals delta x, change in position, otherwise known as displacement, over delta t, which is elapsed time. So displacement over the change in time, or what's known as the elapsed time. Now, elapsed time here, most of the time, anytime you have delta, it's always going to be the final value minus the initial. In most cases with time, our starting time is usually 0. So when we do final minus 0, it's the same thing as the final. So a lot of times you will just end up solving this, the average equals displacement over time. It is an elapsed time, so if you're not starting at 0, you need to subtract the final time minus the initial time. When looking at instantaneous velocity, we're looking at the velocity of a specific moment in time. Instantaneous velocity is therefore a little different than average velocity, and average velocity is a lot easier to calculate. Total displacement divided by the time will give us average velocity. Instantaneous velocity, find that velocity in an exact moment, is much more complicated to solve for unless you have very, very specific data that's down to the thousandths of a second. You can actually solve for it, but it takes calculus using the limit function. So we're not going to use instantaneous velocity as often in this course because we do not have the math background. This is an algebra-based physics course, so we're not going to use the calculus to solve for instantaneous velocity. The difference is really easy to see when you think about your drive to Woodward. You may drive to Woodward at, say, an average velocity of 35 miles an hour. But at any given moment, you may be going at 0 miles an hour at a stoplight or at a stop sign, all the way up to, say, 60 or 70 miles an hour on the interstate. The instantaneous velocity would be your velocity if you looked down at the odometer on your car and saw the speed at that exact moment, whereas the average would be your total distance to Woodward divided, or displacement divided by the time. So we will occasionally talk about instantaneous velocity if we have a specific example where we can look at that, but most of the time we'll be solving for average velocity. In the next video, we'll look at some example problems solving for displacement and velocity.